The average ocean depth is 3.7 times 10 to the third power meters. The area of the oceans is 3.6 times 10 to the power 14 square meters. Estimate the total volume of the ocean in liters, where 1 cubic meter is equal to 1,000 liters. Give your answer in scientific notation or standard form. Now, the formula for the volume is area times depth. Now, what is the area? Well, the area is 3.6 times 10 to the power 14, and the depth is 3.7 times 10 to the third power. And so we have 3.6 times 10 to the 14 times 3.7 times 10 to the power of 3. Now, what we're going to do here is we're going to group all of the decimals, and then we're going to group all of the numbers that have base 10. So what we have here is 3.6, right, times 3.7, all right? And we have 10 to the power of 14 multiplied by 10 to the third power, all right? So we have the decimals here and the number and the numbers who has base 10 are grouped together. Next we multiply, we have 3.6 times 3.7, that gives us 13.32. And notice that these two terms have the same base, which is 10. And so we are multiplying them. And whenever you have two terms that have the same base and you're multiplying them, you have to add the powers. And so we have here is 10 to the power of 14 plus 3. And so we have here is 13.32 times 10 to the power of 14 plus 3. What is 14 plus 3? Well, 14 plus 3 is 17. So we have here is the volume is equal to 13.32 times 10 to the power of 17 centimeters cubed. Now, this is the volume in cubic meters, all right? So this is the volume in cubic meters. We have 13.32 times 10 to the 17 power centimeters cubed. But we want the volume of the ocean in liters. And remember, 1 cubic meter is equal to 1,000 liters. So we have to convert this volume into liters. And so we have to multiply it by 1,000. And we're going to take this 1,000 and multiply it by 13.32. So we have 13.32 multiplied by 1,000. And that gives us 13,320. Okay. So we have 13.32 multiplied by 1,000. That gives us 13,320 times 10 to the power 17. But we have to express this in scientific notation. So this number is not this number. If we have to express this in scientific notation, this number is the problem because this number has to be any number from 1 to 10, but not including 10. And this number is too big, so we have to make this number smaller. It has to be a number, any number between 1 to 10, but not including 10. Okay, any real number from 1 to 10, but not including 10. And this is too big, so let's make it smaller. So we're gonna, the decimal point is here, so we move it over 1, 2, 3, 4. So we move it over 4 times. So we move it over 4 times to the left. Since we move it over 4 times to the left, we have 10 to the power of 4 because we moved the decimal point 4 times to the left, all right? And so the decimal point is right here, so it's 1.3320 times 10 to the power of 4 multiplied by 18. And here we have 10 to the power of 4 times 10 to the power of 18. Notice that we have two terms that have the same base, right? And we are multiplying them. So if you have two terms that have the same base and you're multiplying them, you have to add the powers. And so we have is 1.3320 times 10 to the power of 4 plus 8. So we have to add the powers. And when we add the powers, we have 21. So the volume in liters is going to be 1.3320 times 10 to the power of 21 liters. And that's the answer to this question in scientific notation.